Hello friends, this video on Ray Optics part 47 is brought to you by examfear.com. No more fear from exam. Please make sure that you have watched all the videos till part 46 before going ahead with part 47. The compound microscope. So what was a compound microscope? In the compound microscope, it came into picture for better magnification. It consisted of two lenses. Both were convex, but both of them had different focal length. So one is called the objective and the other lens is called the eyepiece. So a combination of two lenses together formed a compound microscope with better magnification. So how did this function? Here, this is the objective, the lens with a greater focal length, and nearer to the eye is known as eyepiece. So the lens which is nearer to the eye, closer to the eye, that is eyepiece, and the other one, that is the smaller one, is the objective. So in this case, this is known as objective because it is closer to the object, and this is called eyepiece because it is closer to the eye. So now when this is my object AB, so this object forms this image B dash A dash by the first lens. So this image B dash A dash formed by the first lens, it is a real inverted image and it acts as an object for the second lens. And as a result, the final image B double dash A double dash is formed. So if you compare the size of the original object AB and the size of A double dash B double dash, you can see by what extent it got magnified, because it got magnified twice. First it was magnified by the objective and then again it got magnified by the eyepiece. Right? So now the first image which was formed, it was formed in such a way that it is near the first focal point of the eyepiece. So as a result, the next image which was formed is again a magnified image. So this second lens behaves in a similar way as that of the simple microscope. If you see that for the first lens, it gave a real inverted image. But the second lens, it gave a virtual erect image. This was also negative. Here also it is negative. So it gave a virtual erect image. So in this case, the first image I1 is a real inverted enlarged image. And the final image, that is I2, is a virtual, erect, and obviously enlarged image. Right? So now we will look at the magnifying power of a compound microscope. So first let us look at the magnifying power of the objective. So it would be nothing but the height of the image by the height of the object. Right? So in this case, if you try to see, this is the height of the image and this is the height of the object. Right? So when I talk about, if you look at it, by looking at the diagram, you can say that tan beta in this triangle, tan beta is nothing but h dash, and this is equal to h dash divided by h. So tan beta is nothing but h dash divided by L. What is this L? L is nothing but this distance from this point to this point. Right? Also, looking at this triangle, we can say that tan beta is also equal to h divided by this distance. What is this distance? This is the focal length of the lens. Right? Here it is given. This is the focal length. So this is h by f naught. So from these two equations, you can say that h dash by L is equal to h by f naught, or we can say h dash by h is equal to L by f naught. Therefore, we can say that the magnification of the objective is equal to L by f naught. Now what is this L? L is known as the tube length of a compound microscope. And what is this length? What is this length L? L is nothing but the distance between the second focus of the objective and the first focus of the eyepiece. So that is known as the tube length. So here if you see, this is the first focus of eyepiece and this is the second focus of the objective. So the distance between these 2 points is known as the tube length. So this is how we calculated the magnification of the objective. So now let us try to calculate the magnification of the eyepiece. Now when I look at the eyepiece, I mentioned in the previous slide that the eyepiece behaves in a similar way as that of the simple microscope. In case of simple microscope, we found out that magnification is equal to 1 plus d by f, where f is the focal length. So here focal length of the eyepiece is equal to fe. So 1 plus d by fe. Right? So this would be the magnification if the image is at a near point. This is exactly the same case as that of a simple microscope. If image is at a near point. And what if the image is at infinity? If image is at infinity, in that case, the magnification of eyepiece will be equal to d by fe, right? That is the same thing which we derived in case of simple microscope also. So therefore, what would be the total magnification of a compound microscope? So total magnification will be equal to magnification of objective multiplied by the magnification of eyepiece. So magnification of objective is L by f naught and magnification of eyepiece, let us consider it as d by fe. So this would be the total magnification of a compound microscope. So for increased aim or for larger value of magnification, the focal length of the objective and the focal length of the eyepiece should be small and lenses should be large, so that the L is large. The lenses should be large but the focal length should be less, so that f0 and fe are small but the tube length is more. Right? So I hope you understood what is microscope, how does it work, what is a simple microscope and what is a compound microscope. Thank you. Please visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thank you once again.